everyone and welcome back. In today's video, we're going to be exploring Class 9, Chapter 1 Number System. Very easy chapter, for Class 9 that is. So, let's revise a little bit. Integers are positive and negative numbers till infinity. Rational numbers are any number that can be presented in a form of P by Q, where P and Q are integers, and Q is not equal to 0. Okay, let's rub this out and move on. So, one doubt that you might have is that why do we do the same to both sides? So when we're doing this, so if we are multiplying the denominator by 10, we need to multiply the numerator by 10 too. So why do we do that? So if you do times 10 times 10, that is equal to 4 by 1 times 10 by 10, right? And 10 by 10 is 1. So what are we doing? Nothing. We're just making it look on a larger scale. Okay? Nothing too much that we're doing here. Okay. Yeah, there's no change. Irrational numbers. What are irrational numbers? Now, underroot number, where the underroot should not be a complete underroot. So what's a complete root? Complete root is like if you have under root 4 is equal to 4, under root 1 is equal to 1, under root 4 is not equal to 4, it's equal to 2, under root 1 is equal to 1, under root 25 is equal to 5, right? So those are complete roots. Incomplete roots can be, let's rub this out, under root 5. Now, do you know the answer to under root 5? Because we haven't got it, but if you Google it up, you're surely gonna find it. So this is not a complete root. This does not give us a whole number, okay? Or an integer. You can say, sorry, that moved the whole thing again. Okay. Now, this one, under root 5 is irrational, while under root 4 is equal to 2, so it's rational. Okay? Now pi is also irrational because it's 3.14159265358 and so on like that, right? So it's a very big number. That's why pi is irrational. Also, repeating pattern decimals like 0.0100100001 and like that, because each time the 0 is increasing, right? It's not really a pattern like 0.3033030. No, it's not like that, right? So that's why it is irrational. Now we'll understand why it's irrational just in some time as we come to the later. Now, plotting irrational numbers on a number line. Right? So how do we plot irrational numbers on a number line? Now, under root 2 basically, which is under root 2. How do we plot that? Now, for roots, we use the Pythagoras theorem. Let me show you how. So you know that a square plus b square is equal to c square. Meaning if you draw a right angle triangle, a square plus b square is equal to c square. Right? So, now let's use that formula to make it. Now, so h is equal to a square plus b square. Now, meaning if you don't have h square, then only h is equal to under root all of that, right? Very simple so far. Now, if h is equal to under root 2, what is equal to under root 2? You can say, because 2 is equal to 1 plus 1, under root 2 is also our h is in under root, so under root 2 will be equal to 1 plus 1 because it's a 2, so 1 plus 1 is 2. Now we have to write 1 square plus 1 square, and we don't have under root 2 square, right? So we need to put all that under root. So it's going to be under root 1 square plus 1 square. Okay? Now, because 1 square is equal to 1, so it won't make a difference. So, under root 2 is equal to 1 plus 1. How is it equal to 1 plus 1? Because under root 1 square is equal to 1. And 2 is equal to 1 plus 1. So under root 2 will be equal to 1 plus 1. Okay? Got that so far? So we've got the height, which is 1. We've got the base, which is 1. And this is going to be our under root 2. Okay? So we've got under root 2 somewhere along here. Now what if you have under root 3? Now under root 3 is equal to 1 plus 2, right? So if you have under root 1 square plus under root 2 square, so under root 2 square, what is that going to be? Basically 2. So 1 square plus 2 square. So it's going to be, base is going to be our under root 2, and our, you can say, perpendicular line is going to be, so if we say that our base is under root 2, then our height is going to be 1, and this is going to be under root 3. Then you can plot it over here by using a compass. So you open it this much, and then you can plot it on the line like that. Okay? So that's how you plot under roots. Now we're going to be learning about different types of decimals. Now there's recurring decimals where you have 0.33333 and so on. Or you have recurring decimals like 0.123, 123, 123, 123. So this is in a pattern. Well, this is just one number repeating. So non-recurring are the numbers that I told you before: 0.01, 001, 0001, 0000001. So like that. So they are not recurring because that pattern is not getting repeated. It's getting added on to. You see? Terminating. Terminating meaning remainder is equal to 0. So if you have, that's under root. If you have 10 and divide that by 3, so let's put 3 on the top. That's going to be 9 and 1. Put the point over there. 10, 3, and then it will keep on repeating 3, 3, 3, 3, 3. So then this the remainder is never 0. So that's why it's not terminating. Terminating example can be 0.34 or 0.5. Those are terminating decimals. Then we've got non-terminating. The example can be this. Okay? So for irrational decimals, any number which is non-terminating and non-recurring is a rational number. Now let's look at how to plot these numbers on a number line. The best way to do it is magnification. Now plot 5.35 on the number line. We draw a number line and let's magnify from here, because 5.35 is going to be somewhere around 5 to 6, right? So let's magnify that. Now we've got 5 here, 6 here. And then we put 5.1, 5.2, 5.3. Now we've got our 5.3, which is somewhere around there. Now we expand 5.3 to 5.4 because what do we have? 5.35. So we've got 5.3 over here, 5.4 over there, and we've got 5.31, 5.32, 5.33, 5.34, 5.35, which is going to be in the middle. So that's our how to put it on a number line. Now operations in real number. Real numbers are any number which is irrational and rational. Okay, so how would we do the addition? If you have 2 root 5 plus 2 root 6, this is not solvable because both of these roots are incomplete. So it's gonna stay like that because we can't really add these two or do anything with them. While if you have 2 root 5 plus 3 root 5, then you can do 5 root 5. Okay? Multiplication. In multiplication, you can do 2 root 5 times 6 root 5 is going to be 2 times 6 is 12, and root 5 times root 5, which is root 5 is square, is going to be just 5. So you do 12 times 5, which is equal to 60. Then we've got root 3 times root 2 is equal to root 3 times 2. Okay? So we just get root 6. Division can be root 15 by root 3. Now we just do root 15 by 3, which is equal to root 5. If you have 8 root 5 by 2 root 4, then you just divide 8. 8 by 2 is equal to 4, and root 5 by root 4, which is basically like that. Okay? Now, these are some images that I've got, which we're going to look at. The sum or difference of a rational number and an irrational number is irrational. Okay? Sum or difference, meaning irrational plus rational is going to be irrational. If you have rational plus rational, that is going to be rational. Rational minus irrational is going to be irrational, okay? So that's what they're talking about. Let's rub all that off and move on. The product or quotient of a non-zero rational number with an irrational number is irrational. So if you have any non-zero rational number, r times I is going to be I, okay? And r by I is going to be I too. So if you have irrational in there, it's gonna make the whole thing irrational. If we add, subtract, multiply, or divide two rationals, the result may be rational or irrational. Some properties that we are gonna look at is under root a times under root b is equal to under root ab. Okay, so we've got under root 3 times under root 2, which was under root 6. Another one, under root a by b under root a by under root b is equal to under root a by b. Just going to be done with this example. Then we've got under root a plus under root b in a bracket that we've got in brackets under root a minus under root b. Now that's an identity, right? We remember that as a square minus b square identity. So because under root a square is going to be a, so that's going to be our identity. And then you can use this for that. Now these images were provided by Class 9 Maths and Science, which is Learn with Fancy. Please do subscribe that channel. Also subscribe our channel for more of these videos. Hope you understood everything, hope you learned something new, and I'll see you in the next video. Till then, take care and bye-bye.